Hi everyone, today we're going to study addition and subtraction of radicals. First, let us define like radicals. Like radicals are radical expressions with the same index and the same radicand. Example, 5 cube root of 7 and 4 cube root of 7. So we see here the radicands are both 7 and the indices are both 3. So these two radicals here are like radicals. Take note, we don't care about the numerical coefficients. Let's go now to addition and subtraction of radicals. As a rule, in adding or subtracting like radicals, add or subtract the numerical coefficients and copy the same radical. In symbol, we have the a nth root of x plus or minus b nth root of x. The answer here is the a plus or minus b, and then we affix the common radical, the nth root of x. Take note that when radicals are not like, it cannot be combined. Let's have example 1. The 5 cube root of 7 plus 4 cube root of 7. Let us check the radicand and the index. So the radicands are both 7 and the indices are both 3. So these two are like radicals. So we can now add the numerical coefficients 5 plus 4, and then the common radical is affixed here. Next, we're going to simplify now the 5 plus 4, it becomes 9 cube root of 7. So this is our final answer. Let's have the second example. Square root of 20 plus 3 square root of 5. We can see here that the radicands are not same. In here the radicand is 20, here the radical is 5, although the indices are both 2. Still, these radicals are not like. What we will do is to simplify the radical if possible. It means in the first radical here, we're going to remove a perfect n square factor. Then later on the simplified form, we will check again if this radical square root of 20 becomes like with the other radical. Now the 20 is now factored out into 4 times 5. So one factor is a perfect square, and that is the 4. And then we just copy the plus 3 square root of 5 here. Then we're going to show that this 4, the perfect square number, is equal to 2 square. Then we're going to distribute the radical sign to the 2 square and also to the 5. So we have here the square root of 2 square times the square root of 5, and then the plus 3 square root of 5 is copied down here. Next, we are going to cancel the radical sign and the power 2. Only the number 2 comes down here to be multiplied to this square root of 5. Then we'll just copy this 3 square root of 5 down here. Now we were able to simplify this square root of 20. Now becomes 2 square root of 5. So we can see that they are like terms now. It means we can now apply our rule in addition of like radicals. So we will add the numerical coefficients 2 plus the 3. Then we copy the common radical, the square root of 5. So simplifying further, the 2 plus 3 becomes 5. And then this square root of 5 is affixed again. So this is our final answer, 5 square root of 5. Example 3, the square root of 32x raised to 7 minus the square root of 50x cubed. Obviously, our radicals are not like. The radicands are not the same. So what we'll do is to simplify both radicals. We're going to factor out the radicands of each of these radicals. So we will be guided by this principle. For the number, one factor must be a perfect square. Since our index here is 2, so we're looking for a factor that is a perfect square. It means, in other problem, if your index is a cube root, you must look for a perfect cube factor. In the first radical, the number 32 is factored out into 16 and 2. For the variable x raised to 7, there is a clue here how to factor out that variable. It says one factor must have exponent of highest multiple of the index. Our index is 2. So the factors for x raised to 7 are x raised to 6 and x. For the second radical, the 50 is factored out into 25 and 2. We know that 25 is a perfect square number. For the x cubed, factors will be x squared and x. And then we're going to show that this 16 is the same with 4 square. Then I copy the 2 here. For the x raised to 6, I'm going to represent this to be a value with power 2 because our index here is 2, but the value inside here must be x cubed. So checking here, if I multiply the 3 and the 2 powers, I will get back to that power 6. And then the x factor will just be copied down here. On the second radical, the 25 is now represented into 5 square, and the rest we just copy down here. The next line is we're going to distribute the radical sign to each of the factors inside the radical. In the first big radical, we have now this square root of 4 square, and then times the square root of 2 times the square root of the square of this x cubed times the square root of x. For the second radical, we have the square root of 5 square times the square root of 2 times the square root of x square times the square root of x. And then we're going to simplify further. In this first term here, I'm going to cancel the radical and the power 2. So you see, only the base form will come down here. The square root of 2, there is no change. I will copy here. For this expression, I will cancel the radical sign along with the power 2. Only x cubed will come down. For the square root of x, there is no change. Then minus. For the second group, for the first term, I'm going to cancel the radical sign with the power 2. Only the base 5 will come down. The square root of 2, we just copy down here. For this expression, I'm going to cancel the radical along with the power 2. Only the x comes down. And the square root of x, there is no change. I will copy down here. So the next step is we're going to multiply all terms with no radicals, and we will multiply terms with radicals. So the 4 will be multiplied to the x cubed, the square root of 2 times the square root of x. So we will have this 4x cubed square root of 2x. And then minus 5 times x will be 5x. And then the square root of 2 times the square root of x will be square root of 2x. Now on this line, we can now observe that we have like radical. It means we can now apply our rule of subtraction of like radicals. So we're going to add the coefficients of the radicals. In the first group, we have the 4x cubed as the coefficient, and then minus. In the second group, the coefficient of the radical is 5x. So we'll now put them together, the 4x cubed, and then minus the 5x. Then we will copy the radical, the square root of 2x. We cannot combine this 4x cubed minus 5x because they are not like terms. So we'll just keep it as it is. So this expression, the quantity 4x cubed minus 5x times the radical square root of 2x is the final answer. Thank you for watching. See you again next time.